Mr. Brad Nana.
Tom, good to see you.
It's good to see you. I've known you for how many years?
Long time.
Long
20 plus years, I believe.
Some might say too long.
Yeah. Some might say it's never too long.
No, that's exactly right.
Yep.
So you now work for a company by the name of IRISS?
Correct.
First off, who's Brad Nana?
Yeah, so thank you. So let me just introduce myself. So Brad works for IRISS currently.
Okay.
I started my career, it's amazing that they had 34 years ago with a company called Westinghouse. So that's a long time, right? And then, as you know, 'cause I think you were with Westinghouse as well.
I'm 96.
So you weren't with Westinghouse.
Yeah.
Then the acquisition came with Eaton
That's right.
Corporation. Yeah. So Eaton afforded me. So it's a great company. Very fond. Had a lot of friends.
Absolutely.
Yeah. But various roles and responsibilities from sales and marketing to operations to product management just afforded me just a lot of industry knowledge about how to keep people safe, provide equipment that's safe. And that's the message I want to deliver today is it's all about safety and reliability.
And that's what, so we're recording this for Shock Week. Right?
Yeah.
So it's the end of May. May is Electrical Safety Month. So
Yes.
we're in Electrical Safety Month. And you mentioned about safety. I think from my experience and Eden's experience, Eden's always been had a focus on electrical safety. And I was in the metering when you and I were working together. I was in metering and not as close to codes and standards as I am today. So I was doing energy management, right? Which, as many of people who watch my channel know, the National Electrical Code has put a new meaning to energy management because they're using it in different ways from a safety perspective. But we go back in awareness, which is kind of cool where you're at now.
Same thing, right?
You're in awareness, but a different awareness from a perspective of understanding the hazards and risk. So let's do this. So you're now with a company that focuses on awareness from a safety perspective. So why don't you tell me a little bit about IRISS?
Yeah, so IRISS was founded almost 30 years ago. As founder, he's from England, UK.
Okay.
As a matter of fact, just came back from there. We're a global company, and what we try to do when we talk about the awareness, and Eaton uses a lot of acronyms, industry uses.
Yeah.
So the acronym we use is EMSD.
EMSD.
Which stands for Electrical Maintenance Safety Devices.
Oh, okay.
So, and as you can see, pointing to a switchboard with the inspection. So this is an EMSD. It's called Electrical Maintenance Safety Device.
Okay, so that is a window.
That's a thermography window. Yes, sir.
All right. So electrical maintenance safety device.
Correct.
I learned a new acronym, and I have a FILO, first in, last out. So it'll be there for a while at least. So that type of a solution gives you awareness on thermography, keeps the electrical worker out of the arc flash boundary, out of the shock.
Yes.
That's what it makes. That's the key.
Yes. So if I'm going to do a thermography on that cabinet, right? There's only one of two ways to do it. And you just said, I either do it through that inspection window, because it's called an inspection infrared window.
Right.
So I can do a thermography through that window, and it keeps people safe, because the other alternative, which I did it. So I told you I started my career with Westinghouse.
Yep.
I was a service engineer.
Oh, okay.
So 30 years ago, I would put on a suit, PPE.
Yeah.
Right?
Yeah.
I would take off that cover.
Yeah.
Now I'm inside the cabinet.
Right.
I'm exposed to everything that is electrical.
Oh, absolutely.
Which, PPE is part of the risk and risk management.
Yes.
But it's at the lower end because it talks about elimination. So if you can eliminate the risk, that's the best way. But you can't eliminate the risk if you're doing some testing on the equipment.
All right. So risk. We've said this word a few times. Risk. Two key components of risk: likelihood and severity. Right. So when Eden makes solutions to help the severity. We make solutions to help reduce likelihood too.
Yeah.
But reducing likelihood is, in my opinion, ahead of the event.
Hmm.
I mean, if I can help you avoid an event from happening, that's got to be better than reducing the amount of energy or reducing the amount of impact of current through your body through managing the severity.
Yeah.
Right? Because that means something's already happened. Now, so you have these types of solutions that will give you the ability to manage risk through managing or reducing likelihood.
Yes, absolutely.
Because you're on this side of the dead front,
Exactly.
right?
Yeah.
So now,
And I've been inside of the dead front. So here's some facts for you. An arc,
yeah,
which is really interesting. Temperatures that have reached, they recorded at 20,000 degrees Fahrenheit. The
Yep.
surface of the sun
absolutely.
is 10,000 degrees Fahrenheit.
Up close and personal.
So an arc is twice the
Yeah.
temperature of the sun.
Yeah.
So no matter what PPE I have on, 20,000. So just think about that.
Oh, yeah.
Then the
Yeah.
second thing is, and I know you're a hunter. I love to hunt.
Sure.
The ballistics have been recorded anywhere between 2,500 feet per second to 4,500 feet per second.
Yep.
The ballistics, I say ballistics, but the mechanical forces
Yeah.
from an arc.
That's your blast.
Exactly.
Right.
3,000 feet per second. So
Yeah.
even in PPE, I have a
yeah.
blast of 3,000 feet per second.
Yeah. So personal protective equipment is there to protect you from a thermal injury,
Yes.
not from the blast. So we have, if you think about, there are 4 hazards of 70E. You have arc flash, arc blast. They keep those separate.
Yeah.
You have shock, and then you have thermal burns.
Right.
Okay. So now the thermal burns are like the low voltage DC, those applications that won't cause an arc flash, won't kill you from a shock perspective, but current through something metal can make it pretty hot, right?
Yeah. Yeah.
But we can calculate incident energy with the calories per centimeter squared based on IEEE 1584. But we can't calculate the impact of shrapnel and all the things that you just said. We can't calculate the sound. Right.
Yeah.
So, and then there's the eye damage, right? So you have a huge sound impact to your ears. You have eye damage. You have thermal burns. You have projectiles. We try to make changes to avoid all of that. That's our challenge.
Yeah.
Now, 110.3 in 70E is the risk assessment. And we talk about the hierarchy of risk controls. Okay.
Yeah.
Now, what chapter 1, what NFPA 70E is trying to drive you to is establishing an electrically safe work condition, right? But in thermography, can you achieve the goals of thermography while you are in an electrically safe work condition?
So you can't if you're removing the panels.
Right. Right. Yeah. Well, also that's the thing. So to actually do the job, you need to be drawing current, a certain percentage of current. Right?
Yes, exactly.
So you need to have the equipment energized. And let's take these out of the picture. Before that, you have to remove the dead front. You have to expose energized parts. That is a definition of justified energized work, because you can't get it done without it being energized, and you do have to expose your electrical workers. So that means if you're at service entrance equipment, your arc flash boundary, if it's in feet, anybody within that arc flash boundary has to be dressed. So I don't know how close I'm not a thermography expert. I don't know how, if I'm 20 feet away, can I do thermography on a turbo? I highly doubt it.
Yeah. No.
You're going to have to be close.
Right.
So the arc flash boundary, and the big challenge when you are doing thermography, it's not necessarily the few seconds it takes to get a picture. It's dress it up, undressing, right? So you got to get dressed. You got to not be dressed. You got to get all that stuff off. And then you got to get in to do your snap. All right, I'm done. And then button it all back up.
Correct.
There's a lot of time for every single termination.
Yep.
So what you're saying with this type of a product, you eliminate having to dress up. I don't have to worry about the arc flash event because I'm standing. The only interaction I have with the equipment is to open that little door.
That's true.
Now, what's behind that door? I see a honeycomb, but
there's a polymer lens that you shoot through with the thermography.
Yeah, okay, wait. Let's talk about the lens.
Yeah.
You said a lens. I think plexiglass.
It's very similar.
It's very similar.
Yeah.
But is it just a plastic?
It's a special polymer that will allow the thermography camera to shoot through it. So a plexiglass, obviously, or a window, has reflective properties that the thermography will not penetrate. So it's a very special, unique design. It's called a special polymer.
Okay, so I just can't go to Tom's garage
and put on a plexiglass. No, you can't.
Okay. So there's thought in the actual the glass material so that the thermography can go through it.
Exactly.
I didn't know that.
Yeah.
All right. Why?
And there's two. So there's a crystal window that most companies will use.
Okay.
And crystal's okay. However, the problem with crystal is it's hygroscopic. It absorbs moisture. So it's not a matter of if it's going to absorb water and it'll eventually fog up so you can no longer shoot thermography through it.
You're not worried about shock hazard. You're just worried about visibility.
You can't see visibility.
Okay.
And then IRISS, what we did, and we still furnish a crystal window because some customers believe it's crystal, it's heavier, it's thicker, it's the better design.
Mm-hmm.
So now we are educating the customer and saying, instead of the thermography on a crystal window, which has a limited warranty, we'll give you a special polymer design that has an unlimited lifetime warranty because it doesn't fog.
Right.
The other thing you said there too is if you remove the panels, it's not only a one-man job, but it's a two-man person, two-man job.
Okay.
Because the other guy has to oversee, and panels can be heavy, right?
Sure. Oh, yeah.
So one man can't do it.
Yeah.
But there's also a check and balance in place with the second man to make sure the person that's doing this thermography is doing it within safety.
That's right. And there is in fact, I was just talking about this. There is a section, and I'll probably show it on the video. I can't remember the exact reference, but there is a section that says in some cases you may need two people on that project. And I mean, I can foresee physically just getting things off of the equipment, absolutely.
Right.
And then the other is while you're but when you actually get everything exposed and you're doing the thermography, you're not in there. You don't have your elbows in there. You're standing out here. So the interaction, the risk that you have is, from a risk perspective, likelihood and severity. The severity is high. You could be. I'm not going to say it all. Always is. Depends on the amount of incident energy. But from a shock perspective, it's I don't care if it's 120, 240, 480. You touch something energized, it holds you.
Yeah, exactly.
So, and especially where the equipment this is going in, you don't have the luxury of GFCIs.
Yeah,
that's going to reduce the amount of temp current passes through the body. So you have a shock risk and you have a arc flash risk. You have to wear personal protective equipment for the arc flash boundary, which could be significant, could be light, depending upon the calculation, right?
Yes.
And then you're relying on whether or not maintenance was performed on the overcurrent protective device upstream.
Absolutely.
Okay, so now you can make the argument that, well, you're doing thermography, so you're probably in a location that is doing regular maintenance, but you don't know. I don't know that. You'd have to verify that the upstream overcurrent device, which is your clearing overcurrent device, has been maintained, which adds another level of complexity.
Exactly.
And you can avoid it.
So think about this too. With the window, I'm getting true readings of what the temperature is behind the panel. If you remove the panel, what did you now introduce? The heat escapes.
Oh, yeah.
Right?
Oh, I never thought about that.
So think about that.
You're containing the environment.
So the heat escapes as soon as you remove the panels.
Yeah.
Also, if you have a cold breeze at all, you introduce that cold breeze that you may not even pick up a thermal related issue because now the panel is removed. the heat hasn't escaped. So you change the ambient.
You're changing the ambient
So,
temperature.
so by changing the ambient, so now is the test a valid test? Because and not many people think about that as well.
No, in fact, I didn't until just now. So now if I look at 70B, chapter 7, section 7.4 is titled infrared thermography. Now, I'm curious. Now I fought hard for a couple things in here. One was that I had an electrical contractor call me one time, and he was like frustrated. And he said he just hired a group to go do thermography at a facility. And, in his mind, he pays X amount of dollars. It's going to take it's going to take a while because you have to get the hot work permits. You have to do all that stuff, dress up, dress down, the whole bit we just talked about. By the end of the week, they were done. So he gets the sample report and he's like, how the heck did you get this done in a week? This is a lot of thermography. And the guy goes, oh, well, we just scan everything. We just walk through and get it all scanned. He said, well, how did you get the hot work permits and take the panel? He goes, oh, no, we don't take covers off. Then he goes, oh, you don't take covers off? He goes, well, do they have IR windows? He says, no. He goes, the risk of taking the covers off in these facilities is we just scan the outside of the enclosure. And
he's not getting anything beyond the panel, which
he's getting the temperature of the enclosure.
Yeah.
But honestly, he thought that was okay, right? He did, it's one of those things where you know enough to be dangerous. Well, you know what thermography is, you know what your temperature, but if you don't implement it correctly. So I got language in 7.4 that specifically said, it says all accessible and necessary covers shall be removed prior to infrared thermography inspection to provide a clear line of sight to the equipment being scanned, right? So I think that language would permit this, but we really got to look at it. It says all accessible and necessary covers. So that has a cover, a door, I would call it.
Yep.
So if I would change that, I would say necessary covers or doors to provide a clear line of sight to the equipment being scanned, which is what that does. It gives you a clear line of sight.
Exactly.
Which I see there's different dimensions on all the windows. How do you know how big of a window that you need?
Yeah, so that's a great question. And it's all subject to blanket change. The different
are there's big ones? There's little ones?
Yeah, the different sizes, and then you got this one covers the whole gutter on the switchboard.
And we have one up on the busway up above,
on the busway,
which is much smaller, and I'll try to roll that one while we're talking about that. That busway is much smaller. So
but in what we're trying to capture is what they call an FOV, with field of view or field of vision.
Yeah.
And what your target is behind that door. I.e., if I look at this window here, I'm able to see visually what's behind there.
Now, that's a honeycomb. Do I need to worry about the angle that I'm coming in? As long as I can visually see it?
Exactly. As long as you can visually see it, put the camera in front of the honeycomb, it's just a reinforcement of the bulb.
Right.
Does absolutely nothing for thermography. It's just designed to reinforce the window.
Okay.
That's the
gives it some support.
Exactly.
All right. Is the glass in front of or behind that?
It's behind it.
Behind it.
Yeah. And there's two reinforced honeycombs on both sides.
Oh.
So otherwise, you could take maybe a pencil on some manufacturer designs and poke through the polymer and break it.
Really?
Yeah. So you got to have this design, and we've been to the test labs, UL, CUL, CSA, IRISS, to do all the testing required.
Okay.
Because we ask the question all the time, what happens in you violated the UL requirements of the switchboard design.
Oh, so you're cutting
because it's metal clad, you're cutting in, but we're actually replacing it with more metal than what was
say there.
Yeah.
Okay, so your strength is still there. You've not. Oh, okay. Well, hold on. I'm going to get back to this, but I like this discussion is good because I get that question too. They'll say when you start cutting anything in an assembly that's a UL listed solution, and now you're going to cut this. Do I need a field device? So hold on. Two things. One is when it's manufactured in chips.
Yep.
The other is retrofit.
Yes, correct.
Now, let's talk about the retrofit, because I know that's where I want to go.
Yeah.
I mean, that's the biggest challenge. When it comes from a factory, that's a no-brainer.
Right.
It's all listed, all good. But if I'm going to be in the field and I'm going to cut a hole in this, or do you sell the whole panel that has the window in it?
Yeah. So the answer is yes to both. So this is a panel gutter replacement that we partner with Eaton.
Right. Yeah.
Right?
Yeah. Yeah. Yeah.
And some of the other OEMs. Yeah. Because they recognize you have to do thermography. They say, okay, we have to do thermography. The code changes. There's one of two ways, which we talked about already.
Yep.
Removing the panel, or doing it through an inspection window.
Right.
So we partner, and Eaton's been a great partner with us. That they've supplied us their drawings. Okay. And then we've taken it to the lab and we've tested what would happen if you simulate the arc with the panel closed.
Right. Yeah.
So, and it passed. It passed the arc flash test. It's an IEC rating.
Okay, so hold on. When you say arc flash tests, are you talking arc resistant equipment, or are you just talking normal? Just the containing of
containing of the pass
of the. Oh, okay.
Yeah.
All right,
but it's not arc resistant. Obviously.
All right, gotcha.
It makes arc res equipment.
Yeah, because I know that's like built like a freaking tank, and I don't think you can put an infrared.
That's correct.
Okay, so if that would ever change, stay in tune, because I'll be the first one to let you know. But yeah, so the temperature rise tests all pass. Any of the standard UL tests that you put a panel board or a switchboard or switch gear 3 is adequate with that one.
With that window on.
Now let me ask. So let me ask you this. Let's say that I have a 1950s piece of equipment. Can you handle that?
Yeah, absolutely. So yeah. So it's not based on the age of the equipment. It's based on the design of the equipment.
All right.
And from the 50s, because you and I have been in this long time.
Yeah.
We talked about some of the old Westinghouse breakers that came over to now. So the metal clad or design hasn't changed that significant over the years.
Right.
So this window, whether it's 50s or most recent designs, it custom steps.
That's pretty cool. So there's no excuse. Whether I have new equipment, you got to make sure that you tell the manufacturer you want that. I don't care who it is. They can all put it in. Yep. It's just a matter of, hey, I want to make this a specable item, because now there's 3 key documents. When I think of risk and managing risk for electrical installations, 3 key documents. The National Electrical Code. Those are your installation requirements. 70B, which is maintenance, and then 70E, safe work practices. I call that the trilogy. They work together. Any one of those falls on its face. Now, the challenge is that this type of solution is not required by the code.
Correct.
So you cannot say, I expect it to be there. You would have to in a specification, whether you're the owner who tells the architect, who tells the electrical contract or the electrical designer that says, look, I want equipment that has this in it. And I don't know if there's a piece of equipment you couldn't put. Let's have an arc resistant. Right. Transformers, we talked about transformers. Transformers, you can put, and that's a tough one there, because the incident energy on the secondary of a transformer is very, right? So, and we'll talk about that. But you don't have an installation requirement. Now, 70E and 70B. 70B has 7.4, which I'm going to go back to. But I read the 7.4.2 talk about the removal of the covers. And it says, in 7.4.1 says, infrared thermography shall be used when required to verify temperature differences of the following: similar electrical components under similar loading. So you have to have the loading. That's the loading. Comparison between electrical components and ambient air temperatures, which was your point, which we just talked about.
Changing the ambient as soon as you take that panel off.
So how would you even do that?
Yes.
If you needed to compare the difference between,
you can't.
You really can't, because you've changed the ambient within that piece of equipment.
That's correct.
All right. So now you could argue that there's probably value in regardless of the ambient. Like if you let it settle out, if you took the covers off
Mhm.
and you said, I'm going to give it some time for everything to balance out. Now I know what my ambient is around this lug, and then I can record the temperature, but you're adding more time in there because you don't want to, and then you have to control whether or not there's a fan blowing,
Exactly. A little breeze.
anything like that would
Mhm.
change your ambient inside that.
Exactly.
All right.
And it may be enough where you're not going to pick up a hot spot.
Oh yeah. Yeah.
Or on a partial discharge, the arcing, tracking, treeing that leads to the cone.
Right.
So you can't pick out any of that up if you're changing the ambient.
Yep. So 7.4.2, we already read. 7.4.3, temperature differences between the area of concern and the reference area shall be documented. And then 4.4, infrared thermography inspection shall be performed at normal circuit loading. So you got to have the load vehicle. It says where normal circuit loading is not feasible, circuit loading of not less than 40% of the nominal circuit loading shall be permitted. So regardless, you're going to need to draw current, which means it's going to have to be energized. And then finally, circuit loading characteristics shall be documented and retained for future reference. So that is in 7.4. Now, the way 70B is laid out, you have a chapter on different products, and then it'll tell you, chapter 9 tells you the frequency, and it'll tell you need to do thermography annually for conditions 1 and 2.
Correct.
Condition 3 is every 6 months.
Yes, that's absolutely right.
Every 6 months.
And based on the criticality of the equipment.
Yeah, exactly. So you have to have the condition, you have to do the assessment of the condition.
Yeah.
And then as part of that, we build in the criticality of the equipment. And there, I know in the first draft, they just made some changes to recognize that criticality could be impacted by the role it plays in the process. Mm-hmm. It's not necessarily just that from a critical nature of safety, but it's also if that is a very important part of if it's on the production line. Right. That machine goes down, you could go out of business. Right. So you don't want an unplanned outage. So that factors in as well. So, all right. So we got thermography. We said the National Electrical Code 70B. We talked about 70B and the frequency, right? 70E. So you help with now. This is just my opinion.
Yeah.
70B requires thermography.
Yep.
You're not going to replace that. You're not saying, oh, you don't have to do that. You just make it easier and faster to get it done.
Correct.
Right.
And
safer. Yeah.
That's the most important.
It was like, I was like, oh my God, he's going to jump down my throat. Safety. Safety. I'm glad you didn't have a hammer in your hand. Bam. Yeah. You're right. It's the most important part.
That's the most.
But the big challenge for a facilities engineer is they have all of this equipment, all these terminations you have to do thermography on. And how much time do you have to get it done, right?
Right.
So you have to do your scheduling. So if you can shrink down the time it takes to get the thermography done, that gives you more time to do something else.
Exactly.
Right. So it can help in your planning phases.
And you got 2 people versus 1 person.
Oh yeah.
You're taking panels off, which may take an hour to 2 hours to what you said. So here's the other thing that people don't consider, and we see this all the time as well. When you put PPE on, I live in the state of Florida. Can you imagine doing thermography in a 40 cal suit in 90-degree temperatures?
Reminds me of my wrestling days.
Yes.
So we used to wear all of that.
Yeah. So, you're taking breaks every 20, 25 minutes.
It's a weight loss program.
Yes, because if you don't, stop.
You
get dehydrated. Yeah. So you got to take scheduled breaks where a single person like myself, in what I have on, I can come up to the door, the cabinet,
absolutely right,
and do a thermography and be done in 10 minutes.
You don't need special PPE. You just need a good qualified person to do the thermography, and then you need a good qualified person to read the thermography.
Exactly, and that's the other thing that's built into the code of NFPA 70B.
Oh yeah, the qualified person
talks about the qualification, which IRISS also does, because we have level 1, level 2, level 3. Inspection IR thermography qualifications and certifications.
Okay.
As well as level 1, level 2, level 3.
So and you guys sell a camera too, right?
And we do. Yes. Yeah. So we combine the complete package. Everything that the code talks about in the thermography,
Yeah.
or also the ultrasound and partial discharge, IRISS offers a combined complete package
All right.
that we can have one guy doing all the testing.
Yeah.
They qualified,
Yep.
trained,
Yep.
certified, and then the documentation as well is very important. And then we have a document.
And that would be important. The person who's actually going through that facility doing all the scanning is going back and looking at all those scans because now he knows or she knows I was there and this is what I was looking at. And maybe, and then you can understand the notes you took too when you're doing that because you may be noticing other things about a piece of equipment that, and a reason why you maybe scan something that you normally don't.
What we coined, here's another acronym for you. We'll give you another acronym. But IRISS has coined, and we're developing a program. We've developed a program called ODSR. And ODSR stands for Operations Driven Safety and Reliability. And so why you talk about a facility manager?
Yeah.
One guy to the operator who's operating the equipment on a daily basis. So we're giving the training and development program to the operator because they're the ones that are closest to the equipment that know it the best, as opposed to a facility manager who may be 1 or 2 or 3 people within a complete facility versus 20, 30 operators.
Yeah.
So we coined this operations-driven safety reliability. We put together a program, teaching them with thermography, with ultrasound, with a document, qualifying them with certification, a training, and then a documented program. But we're taking a leap to the operator as opposed to the facility manager.
That's cool.
Which is big time savings as well.
Yeah. That's pretty cool. All right.
Anyhow.
So let's talk about, okay, so IRISS makes, to your point, you just went through, you provide a services as well. I'll call that just service, right? So you have, I'm going to just read through this. So I went to your website.
Yeah, good.
You have IR inspection windows. You have CAP series, VP series, and Flex IR. I like these words. I don't know if your marketing person came up with all this stuff or what.
And he did.
Yep. So what's the CAP series?
Yeah, so CAP is a square window.
Oh, it's like that.
So it's that one. And it comes in various sizes, a 4-inch, a 6-inch, 12, 18, 24.
Okay.
So it covers a wide range of switchgear. That window is, looking at it, that's an 8-inch window.
An 8-inch?
So I can tell you, but yeah, that's 12.
12, I was saying.
So the CAP CT 12. So it looked like, but
all right,
various sizes subject to
12 inch, and then this would be your different.
And that's a Flex IR.
Oh, that's
a custom panel. So the Flex stands for custom panels,
it's
custom
like
designs.
Eaton's Flex Centers.
Exactly. Yeah, like Eaton with your Flex Center.
Yeah. So you can make, so if a customer, if I was DuPont or ExxonMobil or something like that, and I said, I want these things, but I need these sizes, you could make whatever you want.
Exactly.
Yeah.
Right. The only thing we ask customers to send us either a copy of the panel, or the drawings, and then we'll make it for you.
All right.
And like
a blurry picture wouldn't cut it?
No.
Okay.
Like Eaton did. They sent us the gutter drawing, and they said, we want that to look like it's part of the gear.
Sure.
So we send these gutters to them with the windows already, and
I would bet
it looks like it's a retrofit.
I would bet that if I was a big facility, whatever brand of equipment that I had, if that facility said, I want IR windows, they could probably, if it's a GE, Siemens, Square D, or us, or whomever, they could probably contact the manufacturer and say, I need, here's my order number for that equipment. I need you to send that over to Brad Nan.
Absolutely. Yeah. It doesn't matter the OEM, the manufacturer.
Okay.
If you want a custom window, you send me a drawing and we'll make it for you.
Yeah. All right. So that's the Flex IR.
Yep.
The CAP is the square.
Window.
What's the vice president, the VP one?
Yeah.
Is that like gold?
So yeah, it could be gold. but if it were me, I would get the custom panel. So think about
the custom panel. That's the
Flex IR.
Okay.
Why? I'm taking off 1, 2, 3 bolts.
You're replacing the entire
panel, as opposed to taking the panel off, cutting it, getting the window. So I'm talking maybe a 1 hour installation for the window. And
Okay.
there's nothing wrong with that as opposed to a 10-minute.
Are they listed?
They are.
Okay, so that's the other big thing. If you're going to cut that in the field, and apply it, you're going to probably, now, I could argue I'm not pulling a permit, but technically the AHJ is going to probably want a third-party review to make sure that everything was done correctly
That's correct.
and all that good stuff.
Yeah.
But you probably have a good instructions, right?
Absolutely.
So, okay,
Yeah.
so you may not need that either way, but it's a lot less work.
And again, it's been tested. Even though this one was cut in,
Yeah,
that whole panel has been tested
that's right.
in a high power lab to say, okay,
Okay.
you have not altered the mechanical or electrical
Sure.
operation of that piece of equipment.
So then I call you, I tell you what I need. I don't have to send you my panel. You make the new one. All I've got to do is come in, take those bolts off, put the new one on, and I'm done.
Then you're done. So
Alright.
if the VP
Yeah.
was saying what is the best design, it's certainly the Flex IR.
Okay. So then what's the VP series?
So the VP series is a round window.
Well, you asked me about this.
Yeah, I was
know
looking
we
for
have a
some
round window in here somewhere. If I find the round IR scan window, if I find the round IRIS, I will.
you can. So we got one.
We got one here.
We got to show it to you.
We have Vanna. Vanna's going to bring it over.
Yeah.
Oh, this is perfect.
There you go.
Look at that.
So-
left. Look at this.
So that's the round window.
I know we have
And that's most of the manufacturers in this space have a round window.
Oh yeah,
And it's a great window.
yeah.
But you're limited on the size of that window. That's a 3-inch window. You're limited to a 4-inch window. Where the cap series is the square window, you're not limited on size.
Yeah. Okay.
So
Wait, what's the size limit on the round one?
so you have 3 round. You have a 2-inch, a 3-inch, and a 4-inch. So the
2,
maximum
3,
you
and
can
4.
do on a 4-inch, where you don't have a limitation on the square, which is the cap series.
Gotcha.
Yeah.
Oh, look at that. All right, so that's basically what's over here, but smaller.
Smaller.
And then the round one. Oh, I see. So you have a cover on it.
Exactly. And that's how you pass. And you can see all the ratings that are published on the cover. The UL ratings, the CUL ratings, the IC ratings. That's how you pass those ratings because it's also covered.
Aaron, am I screwing the right one? You are. The top one?
It'll pivot up.
Oh, it pivots on the bottom one. All right. Oh yeah, I see this is
Those
coming on.
open.
Oh,
And you
I didn't even
pivot.
have to do that. Then I pivot.
Yeah, there you go.
Oh, look
Now
at
there it is.
that. And then that's probably the same diameter as my IR window.
Exactly.
Oh man, I love it. And it's like a,
But you can see the durability
Yeah.
is polymer.
oh yeah.
Without that reinforced
Now,
put-on.
if given the challenge, I can probably break it.
Yeah, you can. Absolutely.
I can
And there'll
break-
be people
Just
that
ask
will-
my wife. I can break
yeah.
anything. Oh, and you're right. I can feel it. The honeycomb is on both sides. So you're sandwiching
The polymer.
the polymer inside.
Okay.
Okay. So, all right. So we talked about the integrity of the enclosure. We talked about the retrofit capability. Trying to think if there was I don't think I had another question. We talked about the listing. These are listed.
So here's the question that gets asked all the time.
What's that?
Because we were talking about code changes.
Oh yeah.
And these code changes are wonderful. And what's the purpose of the code? To keep people safe,
That's right.
right?
That's right. Yeah.
We say you work safe, you're home safe, because there's nothing worse than somebody getting injured on the job.
Right.
So that's what we're trying to do is keep people safe at work so they can go home safe to the families.
Sure.
The question that gets asked to me all the time, and I talk about the code. Well, what happens if we don't do it?
If you don't do infrared.
If we don't do thermography, we don't abide by the code. It's a suggestion, right?
Yeah, well, it's in 70B. Okay, so here's the thing. It's in 70B, and 70B is not necessarily adopted. So it's like 70E. You don't have to do 70E.
Exactly. So you just hit it. So what
Yeah.
happens if we don't do it? So here's the problem. If you don't do it and you have an event, someone gets hurt.
Oh yeah.
Guess what happens?
So OSHA comes to town.
exactly.
OSHA comes to town.
And you know what they're going to ask? Was this avoidable? And if you could say, yes, it was avoidable, how, then it comes down to this, and then you're in deep trouble. It's the analogy I use. It's driving a car without car insurance. I can take that risk, and people do. People,
You're right.
people will get
You're
away,
right.
and they drive a car without car, and they're okay until they have an accident.
Yeah.
And then they have an accident, and guess who's showing up? Lawyers. Same thing.
Right.
OSHA shows up. Your insurance companies are coming in,
Right.
and they're saying, "How can you avoid this?"
OSHA enforces their laws, but they'll use 70E. And now, so the big change that happened just this last cycle was 70B became a standard.
Yes.
It went from a you could, you should, to a you shall.
Yes.
It was a recommended
should
practice.
to shall.
Yeah. So it went from a should to shall, or you could to, or you would. So now you can look at the document and say, all right, what is your maintenance plan?
That's right.
So that's the other the other misconception I hear is people say, "Oh, my maintenance plan is 70B." Well, no, you need to make your maintenance plan. What is your maintenance plan? Because 70B gives you the recipe and the ingredients, but you need to say, "This is what I'm going to do here at my facility." If you employ these, are you training people on them?
Yes.
Do they know how to use them?
Yep.
Right. And if you are putting those in, are you doing it correctly and safely?
Yep.
Right.
Yep.
So,
and that goes back to the certifications that are required,
exactly,
and the qualifications that's in the document.
Yeah. To make the qualified person.
Yeah.
Okay. I'm gonna have some editing to do. All right. So we want to make sure that we have the equipment in place to get people into safe locations.
Exactly.
These technologies, whether you're using the cap as the square, the VP is the round, and the Flex IR custom solutions is just that. It's a build to order.
That's correct.
Okay, so I send you drawings and we're good to go. All right. How about eSafe Connect thermochromic solutions?
Yeah, great. So this is a thermal device, and I'll show you this. I don't know where the camera is.
Oh yeah,
but here's a good demo of a thermochromic flip, and all that is an over temperature indicator that goes onto cable.
That's this thing.
That's that. So if you can imagine, and you can see that the purple clip, that's on the wire.
Yep.
When that wire heats up, right?
Yep.
You'll be able to pick it up during your thermography.
Okay, so that clip, it's not that I'm going to look at the clip itself and it's going to be a different color. I'm going to use my thermography and it's going to see that clip.
So no, not exactly.
All right.
So let me explain it to you.
Yep.
So, we talk about thermography requirement once a year.
Right.
So what happens when you're not thermography and your cable's heating up? That is the purple clip that goes on to that. Okay. Once it hits a temperature of 70 degrees Celsius,
right.
This is just a visual indicator that not during the thermography, that cable's heating up, it locks pink. And it said, I have thermal issue, over temperature issue with regards to my cable or my termination.
So the physical, and that's changes the color.
It changes the color to that pink. And you can see everything, it goes on purple.
It goes on purple. The pink has already,
it's already changed due to a thermal.
So all you're looking for is these pink flames.
Exactly.
So I don't need, okay. All right. I get it now.
So an operator that's walking by opens up the window.
Yep.
And he sees the wires on that breaker. So I can see that as I'm looking at that. And I see a pink clip.
I got a temperature issue.
I got a temperature issue.
Why 70?
That I need to inspect it. So 70 degrees Celsius. So that's two reasons. The cable manufacturers say at 70 degrees Celsius, that's where the insulation starts breaking apart on the cable.
Oh.
So that's number one. Number two is, according to OSHA, at 70 degrees Celsius, that is a second degree death.
Oh.
So it's an over temperature indicator that if I touch that, it's a second degree. It's hot. Exactly.
Oh, yeah.
And so that's why we've done more on the cable manufacturer.
So if you see something that's pink, this is like this isn't like all right, you know what? Next month we're going to take a look at that.
Exactly. You know immediately.
I know immediately that I've got an issue going.
Exactly. And you don't have to wait for your inspection, which is once a year,
Right. Well,
to do thermography.
that's right. So here's the thing. What 70B tells you is that you can, it's not that you have to wait till then. There are other indicators. You may have to pull maintenance sooner.
Yeah. And
this could be an indicator.
Here's the other indicator. This is an over temperature indicator.
Yeah.
I have something that's heating up within the wires or the bus bar, because we have for bus bar as well. That goes on to the bus bar.
Okay.
Yeah. So that's just a label.
It's a label, and when that's square,
when that turns red, I had a thermal issue related with that bus bar.
Oh, look at that. It says, it has, now in this case, it looks like an off white, and then the red is alert.
Exactly.
So when that square turns red, and you just stick this on the bus bar,
and it's a visual indicator that, okay, the bus bar got hot.
This is the first time and it says high temperature indicator, permanent color change to red if heated over 52 degrees Celsius, 126 degrees Fahrenheit.
Correct.
Now, what if I wanted to order these for 125 degrees Fahrenheit?
So, so think about it. You can go, yeah.
You don't do. I mean, but it's not. So you sell these with that temperature. It's not there's no flex in saying I want an indicator at this different temperature.
No.
Yeah. So there would be a reason for me.
Yeah, exactly.
I was just
so here is a spot. I had these.
Okay, so these are spots,
and you can see on these miniature circuit breakers.
Yeah.
Right.
And one is red.
One is red. So I know at one time that breaker got hot. Why?
Yeah.
I had these. I just moved into a house in Florida.
Okay.
I did a thermography on my low center.
Okay. Because you can.
Because I can. Exactly. Yeah. What did I discover? I had a warm, hot, 2-pole 30 amp breaker.
Okay.
I went over and I touched the face of the breaker.
Yeah.
Because I can. Right.
Yeah.
There's nothing there that prevents me.
Absolutely.
And I felt immediately that's a warm breaker.
Yeah.
Right. So I then put a spot on that breaker.
Yep.
And immediately it turned red. So it led me to say, okay, I got to investigate this further.
Right.
Bad termination in the back of the breaker. Do I have a bad breaker?
Right.
And you know, because you were part of Eaton's arc fault circuit interrupter design.
Yeah, ACIs and GFCIs, all that good stuff. Yep.
How many fires happen in a home that are electrical related?
Oh, absolutely. There's a lot.
I heard
there's statistics around that.
Or 90% of electrical fires at home are electrical related.
Yeah, there's a research paper that's done by I think it's ESFI has data on the number of electrical fires, and you're right. There's a lot that are because the electrical fires happen either, like you said, in a panel board,
exactly,
or behind a wall,
Yeah,
yep, absolutely.
Or I tested this at Christmas time.
Yeah,
my wife is bad habit. 15 Christmas light strings into one power strip.
Absolutely. And we all do
it. I put these dots on that power strip, and immediately they turned red because you could feel how hot it got.
Yeah.
Right.
Yeah.
So,
and if it gets hot enough, like you said, well, when you understand the inside of a circuit breaker with the way it's designed, you'll know that okay, you start pulling current through there, it's going to get warm, and that's what trips the thermal. Right.
The other place that we're seeing these dots is in universities, dormitories.
Oh, okay, yeah.
Think about it. In a dormitory, you have normally two students that are sharing a room, 2 receptacles, one on each side of the wall.
Yep.
And they plug everything into that.
Absolutely.
The hot
because we can.
Because we can. Computers, and cell phones, and everything they can. And then now the university is saying, there's got to be a way to measure how hot these circuits are getting. It's a quick visual inspection.
Yeah.
Indicator.
And you just put it on the front,
and you just put it on.
Now, are these I would doubt there's any standard for these.
No.
So you basically you design them, it changes the color at a certain temperature, and that's the way that is. And there's no standards that I would have to think about by sticking something on the front of a breaker. There's nothing that would not prohibit that.
Correct.
And they'll come off too. So
and if you can think about data centers, we're seeing a lot of the clips
Oh, I can imagine that.
There's hundreds of wires
Oh yeah,
within a data center.
yeah.
And somebody that's just doing a visual inspection,
Sure.
they can't, they can see the difference between purple and pink. As soon as they see a
Right.
pink wire or, pink clip on a
Yep.
wire, they say, I have a thermal related issue within that data set
Absolutely.
that I need to inspect.
Makes it a lot faster, a lot easier.
Exactly.
Now,
And that covers the code change because of the visual inspection.
that is exactly right. You know what? In 9.1, I pulled this out this morning. I was like, okay, what would I think about? There is this continuous monitoring and predictive techniques. Okay, I would throw that into that category where
Absolutely.
you can modify your. It's in chapter 9, so this is your chapter 9 covers the frequency of maintenance. I could use this as an indicator to change my frequency of maintenance because one of these things went pink on me, and now I got to figure out why it's so hot.
Yep, exactly. Here's the other, which I didn't bring with me. We have what we call, and I would tell people, go onto the IRISS website.
A link will be down below or somewhere.
We have a really cool video of what we call thermography.
Oh yeah, you told me about that.
Yeah, it's paint. It's paint that goes on. We can put it on a bus bar, and it will turn red.
Okay. Yeah.
Or we're seeing it on mechanical assets, pumps and motors, because people are wearing out bearings.
Oh yeah.
And why do they wear out bearings? Because they get hot.
Yeah.
Then by the time they get hot and they start to change the sound of how they operate, because they start squilling, they
Right.
get really loud in pitch.
Right.
And then somebody could walk by, especially an operator. So here's where we're trying to get down to the operator level.
Right.
The operator walks by it all the time, doesn't hear it, then all of a sudden you hear something with a bearing. It's like, oh shoot, I got a bearing that's going bad. Now we have the paint that goes on the bearing house or the case that's over the bearing.
I like it.
And it's warm to touch. So now the operator can say, that's turned red. I got a bearing that I'm going to have an issue with if I don't repair it now. So, and that's the application of the paint, either on bus bar or on mechanical assets that are going to get worn.
I like it.
Yeah.
All right. So we've got the we covered a lot.
Yep.
Right. So we covered 70B. We talked about the frequency, chapter 9, frequency of maintenance. We talked about the continuous monitoring and predictive techniques. We talked about the arc flash boundary, getting out of the arc flash boundary. We hit your IR inspection windows, the Safe Connect how do you say it? Thermochromatic. Wow, that was just like rolls off the tongue.
Yeah.
Okay. eSentry Asset Management.
Right.
So that is what? Is that a software application?
It is. So what we do, so the code is also recognized. Talked about thermography.
Yep.
Talked about visual inspections.
Yep.
The code also says you have to have a documented program.
And when you say code, you're talking 70B.
I'm talking 70B, exactly. So they say if you exercise,
That's your
develop your
electrical
program,
maintenance program.
it has to be documented.
Yep.
So how do you document your electrical maintenance program?
Right.
There's only a couple of ways that I know of. You have pen and paper, right?
Yep.
You're recording and what your test parameters are, what they were in the past, what they are today, what the changes are. So that's pen and paper, a laborious process. You can do it a Word document, maybe an Excel document. What IRISS has developed is an asset tool software with a cell phone that you can go up and tags that are on the equipment. You can scan it, and then it tells you all about that equipment when you last tested, what the parameters were, and then when you're done testing it, you type in your test data. You're done. Now you have a documented program, and it's called it's an enterprise asset management system.
It's the eSentry
Exactly.
Asset Management.
That's what we
Come
call
on.
it.
I love the name.
Because that covers now the documentation.
Yeah.
Your maintenance program.
Yep.
Which
and I like the scanning, and it keeps it's all
with a cell phone.
Boom.
Or tablet.
We're doing so much more with QR codes these days. It's amazing. And how simple it is to create a QR code.
Yes, exactly.
And then you put it on the equipment, and then in 70E tells you that whenever you are going to do your hazard risk assessment, you're going to ascertain the condition of maintenance, You go out, you scan it, and you have the information.
Exactly. You talk about condition in the maintenance program.
Yeah.
So this is now your check engine light. An operator,
Sure.
he scans it. You can see the parameters. He can create a work order.
Right.
And you get an alert condition anytime something is outside the parameter. So now the facility manager can get this alert on his phone and say, "Hey, it's just tested.
Yeah.
It's out of
That's
parameter, out of spec. Go test it further and it creates a work order."
Yeah.
So
Yeah.
it's all done with the cell phone.
It's all done with the cell phone. I love it. We do so much with that anymore. All right. So you have the whole management. You also have the services. You talked about that. Ultrasound and partial discharge.
Yes.
Now that's medium voltage only.
That is correct.
5,000 volts right now.
Yeah.
So where do you are you building it in the window?
So what we have is a sensor, and you can see this one. Maybe you cannot see it. There's a port that you plug in an ultrasound device. And now I'm able to hear, and there's a sensor back there. I'm able to hear before I can even see it.
Is that continuously, or is that just when you go and read?
That's only when doing a
Okay.
test.
All right.
But that sensor, and now I'm able to hear the arcing, the tracking,
Right.
the treeing, which leads up to a partial discharge situation in the corona, right?
Right.
So now, before it becomes an arc fault related situation, I'm able to hear it audibly, and then visually, once it becomes a hot spot, I can see it through the thermography. So we're combining two technologies with a window, the thermography, and the ultrasound that I can hear those partial discharge symptoms, or common symptoms.
So you're using audible sound.
Yep.
For partial discharge.
Exactly.
Wow.
And I got one device that I can do it all.
And that would be medium voltage equipment. And is there something inside? You said there's something inside.
Yeah, there's a sensor behind that window that will allow me to plug in.
It's on the window though. When you say it's built onto the window.
There's a port that you plug in.
Okay.
A handheld device that measures also.
All right, gotcha. Okay, so the handheld device.
Device is measured.
Okay. Okay.
And,
All right.
And so you plug that handheld device in, and you're able with.
Now, let me ask you: is there a stethoscope? Is it like a doctor's stethoscope?
Yeah, it's earphones and headphones.
Oh, I like the stethoscope.
No.
Come on.
That'll be the next design.
That'll be the next design. Yeah, call it the Tommy D special. Yeah. All right, so you put your headphones on. Now, are you actually listening, or is it recording?
Yes, both, and it is recording, and it is capturing waveforms as well. So this device is capturing the sound, the frequencies, the waveforms, and you can audibly hear those three: arcing, tracking, treeing, and you can determine based on the waveforms of what you're experiencing.
So do you make that device, or is that someone else? You just facilitate?
So IRISS does not make the device, but we partner up with partial discharge and ultrasound suppliers.
The suppliers, okay.
And we supply that as a bundle package.
Sure. Okay.
But yes, it's like the thermography cameras. We don't make the cameras.
Right.
We partner up with companies that do.
Okay. I saw a camera on your website.
Yeah, and it's not IRISS. IRISS doesn't develop the cameras. IRISS doesn't develop the ultrasound partial discharge devices.
Gotcha. All right.
But we sell it as a bundle.
I'm with you.
Yeah.
Value. It's all about the value.
Exactly.
Okay. So we covered the R inspection windows. We covered the Safe Connect thermochromatic solutions. I'm going to get better at that. East Century Asset Management, and then ultrasound and partial discharge. All of those. In the definition of risk is managing likelihood.
So,
and you're avoiding the severity because you're avoiding the event altogether because you're getting people outside of the air flash boundary, outside of shock boundaries, all of that good stuff. You don't have to worry about dressing up. You're very efficient. You're getting it done. Works into the schedule. And oh, by the way, if you need help with scheduling all of that maintenance, you use the East Century asset management system, and you can have it on your free phone.
Exactly. I'm totally great summary.
Oh, we just. I want to make sure. I'm making sure I can do everything. So here's the thing. I think there are a lot of people that watch my channel that like to hear the latest in technologies.
Mhm.
And I tell you what, the first time I saw the trough on a panel board with an IR window, we even had a residential panel. I can't remember. I couldn't find it. It's around here somewhere. We had a residential panel board with that honeycomb on it. I was like, this is nuts.
Yeah,
It's crazy.
right.
It's unbelievable.
Yeah.
And why would you not want it? Now I can imagine it adds cost.
Mm-hmm.
Okay. But it's going to save you costs too.
Yeah.
Especially if you are trying to meet 70E, because I've spoken to people, I ask them, and I know organizations that are just top notch when it comes to safety, and they are by the book on 70E. They have their own safety plan, all this good stuff. And then you ask them about maintenance, and they go, "Yeah, I think we have a maintenance plan."
Yeah.
You think you have a maintenance plan?
Yeah, you don't.
I mean, you don't have a maintenance plan, right?
Yeah.
And then you should, and we just did this in our Ashford plan. We compared our existing maintenance plan with 70B as the standard,
Mhm.
and we identified many gaps. And we're in the process of now correcting all that and getting all of that back in order. But I'll tell you what, if you're not paying attention to 70B, then you aren't doing 70E, because 70E requires that. So you got some cool solutions, very play very well. They complement Eaton solutions very well.
Yep.
I mean, as shown here, I'm still going to be fighting I'm coming down to our transformer plant, and I'm going to be beating them up, because transformers, in my opinion, need to get those windows in there. So if somebody wanted to learn more about IRISS and the solutions of where do we send them?
Yeah, so the best place to send them to the website at iris.com.
IRISS.com. If anybody who's watching this needs or wants to get in contact with IRISS, how do I do that?
Yeah, so iris.com.
Okay.
And there's a contact us. And then there's also a phone number. But
is that your cell phone?
It's a lot of times it is. Yes.
Excellent.
Yeah.
Excellent.
My phone, like yours, is with me all the time, right?
IRISS.com, right? So there's two S's. What does that stand for? Infrared
Inspection Services and Solutions.
And Solutions. Infrared Inspection Services and Solutions.
Correct.
IRISS.com.
Yeah.
And go to the About.
And go to the About, or, and you see it, because Eaton does the same thing. Solutions, services, products. We have the individual tabs. You can, and there's data sheets and there's spec sheets.
Yeah, there's a lot of really good information.
Exactly. And if you can't find the information, there's a contact us. Please give us a call.
Excellent. And if they want to find out how to implement this in existing equipment, they would go to that website.
They go to the website or give us a phone call.
That'd be the best bet.
Exactly, especially on the custom panels.
Absolutely. And then, so is there anything else that we didn't cover that we needed to cover?
No, I think in summary would be, thank you.
I'll give you the closing.
Yeah. So the NFPA 70E and 70B is the changes of what we said, the should to the shall. So you must, and we use the word must. You must identify electrical maintenance program, EMP. Right. That's tailored to you and to meet your needs in a facility. We have one down in our facility at Fort. You have one that you said that you're going to have in Asheville, North Carolina, Greenwood, Fayetteville, Sumter. I guarantee you they have very similar programs, but they have one adapted to them. So it talks about EMP. It talks about thermography, right? It talks about ultrasound, partial discharge. It talks about documentation. So documented program.
Yep.
How do you document? We talk about our e-centric and the documentation that's done right on the cell phone. So you're not pen and paper, Word, Excel. And then the last is the qualified, certified person doing the testing. That has to be documented. So if OSHA comes in, or insurance companies come in and say, hey, what training did you provide to this person that's doing the testing? And if you got hurt, you hope you have a documented program.
Oh, yeah.
If you don't have a document, then again, OSHA is it's not going to be a good day for you.
Yeah.
Anyhow, that's what we're trying to do. We want people one accident, one injury, and this is very dangerous equipment, is one too many. Stating us the message we're trying to deliver at this great message.
Yeah.
Well, thank you for your time.
Thank you, sir.
Always a pleasure.
My pleasure. All the way around.
Well, I hope you enjoyed that session with Brad Nana. I don't know about you, but I learned a lot about the infrared windows and all of the different services that IRISS brings to the table. Great organization as far as I can tell. I know Brad Nana is a great individual, so really enjoyed my time with Brad and his crew. He brought some good show and tells and very, very knowledgeable. I think he's probably forgotten more than most of us know, and I really enjoyed that session. Thanks for joining on for Shock Week. I hope you're getting a lot out of Shock Week. I know I am. I am, again, getting together with Puppy Paws, making things happen, and great coffee. They sent over Puppy Paws Coffee Company. They, brews for rescues. So great, another great organization. You got to drink your coffee. If you're going to be listening to all of these safety messages, you better be drinking a lot of coffee. And hopefully it's Puppy Paws Coffee and Company. So they also do tea, and they have a lot of different great, look at this. Got a lot of great things, let's get cozy with coffee. So in any case, they've got bandanas if you've got pups. They've got bandanas for your pups. They'll even send you treats in the mail when they send your package. So get your coffee. Hopefully Puppy Paws, we got a 10% discount. Just follow the links down below. And I hope you're enjoying Shock Week. Take care. See you at the next session.